So today we're in 5.4, solving special systems of linear equations. What do you think of when you hear the word special?
Like different.
What do you think of when you hear the word special?
It's not the same from others.
Okay, it's not the same from others. It's going to be different. Who said unique?
Weird.
Yeah, Josh. Okay, yes, unique. Okay, so this is like our exceptions. Do you guys remember back in chapter 1 where we learned infinite solution and no solution? You guys remember that? And that was when our x or our x's canceled out completely and we couldn't solve for x. Do you guys remember that?
Mm-hmm.
Okay, so with special systems, the exact same thing is going to happen. Something is going to come up in today's lesson that's actually kind of familiar to us. Parallel lines. Do you guys remember what is true about the slopes of parallel lines? They never intersect, but what about like the actual number? Could you look at two equations? So I'll just give you one. Y equals negative 3x plus 2. Y equals negative 3x minus 4. Are these equations parallel?
Yeah.
Yes.
How do you know?
Because they have no solution.
Same slope.
Yeah.
Same slope.
Look
They're
at that.
lined up together.
M equals negative 3 on both, right? Same slope. So that still will apply to today's lesson. If the system, if two equations have the exact same slope, they are parallel. You actually don't even have to solve. Okay, that's kind of cool. Like, you don't have to use one of your methods. You literally can just pick out, oh, same slope, so yeah, they're going to be parallel. All right, but now I have other things in the mix. Don't be confused by this one solution. Like, what do you mean by one solution? Literally everything I've done in chapter 5. That ordered pair, if there's an ordered pair that's the answer, that's one solution. That's what I've been doing this whole chapter. Okay? Infinite solution is when everything cancels down to like 0 equals 0. All right? So let's look at just kind of this bringing it all together information. All right? Definitely star this, highlight it. It can be really helpful for you as you start to study for your chapter 5 quiz. All right? So graphing. What am I looking for in a system to know that I should graph? Well, it should be in slope-intercept form or easy to get in slope-intercept form. Can we review slope-intercept? Can y'all say it with me? Y equals mx plus b. Okay? Now, what about substitution? I'm looking for a simple equation where x or y is already solved for. Okay? Now, elimination. Look for the x or y term to be easily canceled out, meaning opposites. I want you to write in the word opposites there to remind you that you're looking for opposites with elimination. Okay, and that's what we learned in 5.3. So what types of equations look like the graphing, the ideal one for graphing, the ideal one for substitution? Okay, well, let's look at this one. What do you think makes this system ideal for graphing?
It's in slope intercept.
It's in slope-intercept. Are these lines parallel?
No, because they
They're same. They don't have same slope.
Correct. They're not parallel, so guess what? At some point, these lines will intersect. I don't know where without graphing, but because they don't have the same slope, I know they will intercept at some point. Okay, so do you see how I can tell that just by looking at it and not even solving? All right, now substitution. What makes this system ideal for substitution?
X or Y is solved for.
X or Y is solved for on which one?
Top.
On the first one. Do you see x equals 2y plus 2?
Yes, ma'am.
So what are you going to do with 2y plus 2?
Substitute it in one.
Plug it in for x on the other one, and then bring it down and solve. Some of you are getting really good at that, okay? Which I'm really proud of you. Some of you are kind of shaking your head like, yeah. Okay, we've got time. We've got time, but I still need you making progress. Every time we work one of these, just try to get one step further in solving. Now, elimination. What makes this one ideal for elimination?
Neither X or Y is solved for. Or no, opposite.
they
Okay.
can be easily canceled out.
Yes, opposites, easily canceled out. Are my x and y lined up? Okay, and then can I look and see these are already opposite? Okay, so I don't have to multiply by anything. I can just see that and Just cancel them out. So does it help you to kind of see, like, this one's ideal for graphing, substitution? Okay, hopefully that's helpful, especially as we start to review for our Chapter 5 quiz. Okay, all right, so example 1. Example 1. Let's look at the first problem. Y equals 3x plus 1, and y equals 3x minus 3. What do you think when you look at that problem?
Parallel.
Okay.
Graphing.
Okay.
Parallel.
So if I were to solve it, graphing would be pretty easy. However, what I want you to be kind of mindful of and look for, I see that they're both in slope-intercept form already. So the first thing I'm going to check is these guys right here. I've already heard it. Connor, what did you say? You said that they're parallel lines. Go back to your definitions. Okay? I'm just going to draw two parallel lines as best I can. Okay? What does it say about the solution of a system of parallel lines?
No.
They intersect.
Okay.
Wait,
No
they
solution.
They don't intersect. Think about it, guys. Whenever I'm graphing a system, I'm looking for the point where they cross. That point is my solution. If parallel lines never cross, there is no solution. So if you can look at a system like this, and this is on your homework too, if you can catch it. If you can look at a system like this and you can say, wait a second, my slopes are the same here. So I know that these are parallel lines. Here's what you can write. Parallel lines. You must write parallel lines. And because of that, there is no solution because parallel lines never cross. The solution is where the lines cross. All right? I might throw that one in there on a quiz or a test. So that one, you get excited. You're like, yes, I don't even have to solve this. I literally can just look at it and I know they're parallel, so there's no solution. Okay? You have a whole section on your homework that says without solving, determine the solution, the number of solutions or the number of answers. So I would say no solution here. All right, now let's look at this next one, the second one. Can you do the same thing we just did on the first one?
No.
No, they're not in slope-intercept. Maybe the first one is. Okay. All right, so what I need to do now is, I heard it. Which method? Substitution. Okay, because elimination, my x's and y's aren't lined up. Okay, and even if they were, I'd probably have to do another step. But I can see y equals negative 5x minus 2. So where do I plug that in on the next one? Where do I plug it in? It says y equals this. Where do I plug it in on the
Oh, why?
4y.
5x plus, and then bring it down and plug it in for y. So that's what I'm going to do. 5x plus, and now I'm going to bring it down, negative 5x minus 2 equals 0. Do you see what I did there? It said y equals negative 5x minus 2, so I plugged it in for y on the other equation. Okay? So now I'm just going to keep solving for x. You've done this in the substitution section. I just now need to combine my like terms. So what's 5x minus 5x?
Cancels. 0.
Cancels out. 0. Those cancel. So what am I left with?
Negative 2 equals 0.
Negative 2 equals 0. Is that true?
No.
Nope. No solution. Negative 2 does not equal 0.
Wait.
Negative 2 does not equal 0. All right, let's look at example 2. I'm going to... Actually, we'll do this one. Okay? We'll do this one. You can use whatever method you want. Okay? Any information that we've already discussed, I want you to tell me what the answer is here for this system. Work together. All right, Avery, what did you notice about this one?
Okay, parallel.
How did you know they were parallel? Guys, pay attention. There's nothing that would cancel, but what do you see about your slopes? That's how I know if they're parallel. Yeah, look, not just the same sign, but they're both negative what?
X.
The slopes are negative 1, okay? So they're parallel because I can see they have the same slope. If they're parallel, I know they will never cross, so it's no solution, okay? So guys, for sure, if you ever see a system that's in slope-intercept form, check to see if those lines are parallel first. If they're parallel, you're like doing a happy dance because you don't have to do anything. All you have to do is just say parallel, no solution. All right, let's look at example 2 now. In example 2, these equations look a little different. What method, raise your hand, what method do you think would be the best method to use? I have 3 choices, graphing, substitution, or elimination. Raise your hand, Michael.
Substitute.
You could do substitution. It's going to be one step on that first equation, subtract 2y. You could do substitution. Mason?
Elimination.
I would do elimination. Okay? Hold on. Don't say what you're timesing it by. Okay? So, look here, guys. We're going to do elimination just to practice the elimination. Substitution could be, substitution could also be an option. Which equation do you think needs to be multiplied? Because if I want to use elimination, I don't see any true opposites. Which equation would you multiply? The top one or the bottom one, Nick?
The top one, you multiply by negative 3.
Okay, so he's saying the top one I need to multiply. So you can either choose X or Y that you want to cancel. It could be either one. Okay, it could be either one. So I'm just going to try to cancel out my X. What can I multiply X by to make it 3X? Or maybe I could put it better and I could say, what would I need to multiply it by to make it the opposite?
Oh, I know.
Negative 3. Negative 3. So now I need you to distribute it all the way. What I've seen looking at some papers is I've seen they multiply by the first term, but then they forget to do it all the way, okay? So, negative 3x minus 6y equals negative 18. Okay, do you see what I did there on that top equation? Okay, now let's bring over the bottom equation that we didn't do anything to.
I have a question.
And I have
Is
3x
it 0?
plus 6y equals 18. And now all of a sudden, well, here I was trying to cancel out my x's, right? That's all I was trying to do was cancel out my x's. But now my x's cancel. What happens to my y's?
They cancel.
They cancel. What happens to my 18s?
They cancel.
0 equals 0.
That's so cool.
Infinite.
Yeah.
Infinite. Okay? So again, I'm seeing some flags here. I'm seeing some markers that say this is a much different answer than what I'm used to seeing in my other sections, because now everything's just canceling out. I can't solve for anything. All right? I want you to do the second one now. Go ahead and try the second one. I want to see if you can identify that step 1. What do I need to multiply one of the equations by? Again, substitution is not out of the question. It just tends to be one that is, kind of a little more of a struggle. So that's why we tend more towards elimination whenever we can. Okay, so on that second one, oh, sorry, I forgot. You got to change that 5 to a 0.
Oh,
Sorry.
infinite
Yeah.
solution.
Otherwise it will have a solution.
Yeah.
Okay. So, yeah. All right. So, what did you multiply it by, though? What did you multiply it by?
Negative 2.
Negative 2. You multiplied it by negative 2, so you could get negative 4x minus 2y equals 0. And now I have 4x plus 2y equals 0. And then they just all cancel again. So when you see them all canceling like that, all right, that's definitely an indicator.
I knew it had to be. I know. You
Have this section on your quiz and your test. I'm going to open it up and I'm going to give you a section on your test that says, is there one solution, meaning there is an ordered pair? Is there no solution, or is there infinite solution? And I'm also going to open it up and say, use whatever method you want. Okay? Please, before you just think you need to start solving it, look at the system. Okay? On these problems especially, look at it. Make sure you're not missing anything that's kind of simple and making it more difficult because you're used to solving these really hard ones. All right? So look at the system and then start solving it. All right? I'm going to walk around and kind of help you guys. So look here, guys. I think immediately elimination because I see X and Y are lined up. X is lined up, Y is lined up. So now I'm going to look for anything to be opposite. They can just be canceled out without me doing anything. Are my X's opposite? Are my Y's opposite?
Yes.
Yes. My Y's are opposite. So what I did was I just canceled out my Y's and I added the rest down. 3x equals 3. I'm sorry, 9. 6 plus 3 is 9. 3x equals 9. Divide by 3. X equals 3. All right, so that's okay. All right, so now that I know that x equals 3, x didn't cancel out. That's only half of my answer. What do I do to find y?
Plug it in.
Plug it back in. Plug it back in. So 2 times 3 is 6. Plus y equals 6. 6 plus y equals 6. Subtract 6. Y equals 0. Put it together in an ordered pair. 3, 0. Okay? Now, some of you solved for y first, and you still got 0, and then you went back and solved for x. That's perfect. That's fine. That was a little bit harder because you had to take an extra step. But either way, you can get it. Did anybody get that? 3, 0?
I got
Anybody get that? Okay. One. Oh, yes. We have to answer this. This is one solution. One solution because there's an ordered pair. I did come up with an answer. 3, 0 is the point where these lines would cross. So it's one solution. See how those can get kind of tricky, like mess with your head a little bit. Okay, so that's it for 5.4. I want to start working on our homework for the last 10 minutes or so of class.